All right, Logan, what's up? Just to go over it real quickly one more time. Classifying triangles based upon their sides, there are three classifications that we have. We have the equilateral triangle right here, where all the angles are the same. Sorry, I made a mistake. All the sides are congruent, so all the sides are congruent to each other. We call that guy the equilateral. The next one we have is the isosceles triangle. That's where you have at least two sides that are congruent. Now, interesting enough, when it says at least two sides, that does mean this guy here is also considered an isosceles triangle. He obviously doesn't like to be called that because he thinks he's more special, but he is technically an isosceles triangle because he does have two sides that are congruent. Moving on to our last one, the scalene triangle has absolutely no sides that are the same. So all the sides are different, and we call those scalene. So this is the first thing I need you guys to remember. Isosceles, two sides the same. Equilateral, three sides the same. Scalene, no sides are the same. All right, so here's our first example. Classify the triangle with vertices 0, 0, 3, 3, and 3, negative 3. So my suggestion, graph this guy out. Real quick sketch, okay? Plot the point 0, 0. I'm going to go ahead and call that A just to give me a reference. So we have A right there at 0, 0. Then B, we'll call 3, 3B. So we go 3 to the right, 3 up, and we have B located right there. And then finally, 3, negative 3, we'll call that C. So 3 to the right, and then 3 down. And we have C located right there. All right, so the next step, we're going to connect these guys just so that you can see the triangle. And that is the triangle that we're trying to classify. So we want to know what kind of triangle that is based upon the sides. So what we're going to do is we're going to apply the distance formula, a variant of Pythagorean theorem. Now keep in mind the distance formula one more time, just a reminder, the distance formula is the square root, right? Remember my house? And in my house, how many rooms? That's right. A lot of you are like, no, not again. Yeah, so we got 2 rooms in the house. And in my first room, yeah, I'm a freak. I put my x's in there. So I have my first x and I have my second x. Now here's the thing about my x's. They don't like each other. So they're always fighting and subtracting. Now, this is where it gets really crazy. My house, I also have my wives. Yeah, I know it sounded like I said wives. I said Y's. My Y's are in the second room, and my Y's really don't like each other. They're also going to subtract as well. But honestly, this is the quadratic formula. This is the distance formula, and we need to memorize it and use it. All right, so the first thing we're going to find is AB. So I want to figure out how long this side is right here. So I'm going to say, let's find AB. So I'll write it down. AB equals the square root. I'll take my first x, which is 0, and I'll subtract 3 from it. So I'll go 0 minus 3 to the power of 2 plus, and then I'll take my first y, which is also 0, and I'll take my second y and subtract it from that and raise it to the power of 2. And this gives me real quick math. We get 9 plus 9, which is equal to the square root of 18. Okay, now I'm going to leave it like that. Normally I would simplify it, but we're just trying to figure out if all the sides, do any of the other sides have square root of 18? Now, if the numbers are come out different, then I'm going to look for different things. Like I might actually plug it into a calculator or something. All right, next, I'm going to find this guy just because it looks like it might be the same as that one over there. So I'm going to find AC now. So my next line, because I'm curious, it doesn't matter which one you find first, second, or third, but I'm going to find AC next. So I'm going to go 0 minus 3. So we're going to go 0 minus 3 to the power of 2 plus the first y, which is 0, and then the second y, which is negative 3. So it's the opposite of negative 3. Notice I just changed the signs of that minus 3 because that's what it tells me to do right there. Okay, so this gives me 9. So some quick math, we get 9 plus 9 because 3 to the power of 2 is 9. Negative 3 to the power of 2 is 9, and we get 18. Ooh. So what we know right now is at the minimum, this thing is isosceles. So this is not a scalene triangle because 2 sides are exactly the same. Now, the last one we're going to find is right here. This is the one a lot of you like because when you have 2 points that are vertical, up and down, or horizontal, left to right, you actually don't have to use the distance formula. You can count. So if I counted this thing, I remember it's 3 spaces up and it's 3 spaces down for a grand total of 6 spaces. Now, that side is definitely different from the others. So all I can say is that this is an isosceles triangle. Isosceles triangle. All right, stay tuned for the next video on the next type of question.